Alright, grade 12s. Today we're going to take a brief look at section 5.2 and how we graph trig functions, specifically sinusoidal ones like sine and cosine, with transformations. So I've taken the liberty of using one of the examples that I gave you for homework, and we're going to look at 3 sine brackets 2x plus 2 pi over 3 plus 2. So we need to look at the amplitude, the period, the phase shift, and the vertical displacement. The order here, the numbers on the side, I'll come back to in a second. So the amplitude is always given by the a value. So that's going to be given as 3, and it's always a positive number, the absolute value of the a value. The period is given by 2 pi divided by the b value. But when you look at this, there is no b, but there are numbers inside here. So I'm going to take out this 2, the number that's associated with x, like we did in chapter 1, rewrite this as y is equal to 3 sine 2 bracket x plus pi over 3 plus 2. That means my b value is 2, and we've been doing this. We did this in chapter 1 and in chapter 2, even with polynomial functions, I think. So the period is 2 pi over 2, over 2, which gives us a period of pi. So we've got an amplitude of 3, a period of pi. Then we've got the phase shift. So the phase shift, the h value inside the function here, tells me that we're going to be moving left pi over 3. So negative pi over 3. And our vertical displacement, our k value, tells us that we're going to be moving up 2. So I can use that to graph the function. Now, like we did in class, we're going to use the box method to do this. So you draw a box, 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, slightly longer than it is wide. Cut it in half vertically, or horizontally, and then in half vertically, and then in quarters. So I've got 4 equal parts to this, with a high point, a middle, and a low point. Now, this is where these numbers come in. First thing I'm going to do is look at the vertical displacement. This tells me where the middle is, at positive 2. If I add and subtract the amplitude to that, I'll get 2 plus 3 is 5, and 2 minus the amplitude, 2 minus 3 is negative 1. So that tells me where things are going to end up, top and bottom and middle. Next, I want to figure out where my graph's going to start, where it's going to end, and where these intervals are going to be. And sometimes that requires a little bit more work. My phase shift tells me where it's going to start, negative pi over 3. My period tells me where it's going to end, or how much later it's going to end. So negative pi over 3 plus pi is going to give me 2 pi over 3. But what are these other numbers in between? Well, what I do is I take the period, and I always divide it by 4, and that'll tell me how much I need to add to this number to get to this over and over again. The problem here is that I've got 2 different denominators. So I'm going to rewrite those with a common denominator of 12. So this is going to become 3 pi over 12. And this is going to become negative 4 pi over 12. Then I can start doing the additions, and it'll work out nicely for me. Negative 4 pi over 12 plus 3 pi over 12 is negative 1 pi over 12. Plus another 3 is going to be 2 pi over 12, which is pi over 6. Plus another 3 is going to be 5 pi over 12. And plus another 3 is going to give me 8 pi over 12, which reduces to 2 pi over 3. Once we know that, then we can look at what kind of function we're drawing. So it's a sine function, and it's positive. So that means it's going to start at the middle and go towards the top as we go to the left, to the right, back down towards the middle, towards the bottom, and back up towards the middle. So I get something like that. Now, if I want 2 cycles of this, or if I want to go from 0 to 2 pi, I just need to draw myself an xy axis, which I've done ahead of time. I use the available space that I have on my graph paper. Ideally, I would do like maybe 12 boxes to pi, but I only use 10 here. if I take pi and divide it into 3 equal parts, I get pi over 3 and another pi over 3 here, pi over 3 and another pi over 3, 1, 2, 3 and a third back there. Is that right? 1, 2, 3 and a third. Yep. So at negative pi over 3, 1, 2, 3, over here, negative pi over 3, and at a height of 2, so I draw a little dotted line to show where the middle of the graph is. I give myself a hint here at the 5. That's going to be my high point on my graph, so these are just boundaries, and negative 1. So at negative pi over 3 and 2, I had a point. That was the start of my sine function. At negative pi over 12, I was at my maximum. It's a little harder for me to show right now. Let's go on to the next point. 2 pi over 12, I was back at the bottom. So 2 pi over 12, that's the same as pi over 6, which is halfway between 0 and pi over 3. So that's right over here. That's where I'm crossing back down. I'm hitting a minimum at 5 pi over 12, and I'm getting back up to the middle at 2 pi over 3. Remember, this is 2 pi over 3 and pi over 3. So my maximum is going to be between these 2 points, just before pi over, or just before 0. My minimum is going to be between these 2 points at 5 pi over 12. And I can get my graph like so, and then I can repeat it. So I see that from my starting point to my end point, halfway between it's going to cross. Halfway between those 2 points will be my maximum. Halfway between those 2 points will be my minimum. And I could identify what those points are using this progression here. So this was negative pi over 12, 2 pi over 12, 5 pi over 12, 8 pi over 12. So this would be 11 pi over 12, 12, 13, 14 pi over 12, 15, 16, 17 pi over 12, etc. Pi over 12, and 18, 19, 20. Okay, so that's an example of how you can graph using the box method and transferring your information to the to your x-y axis or your theta y-axis. Hope that helps.